Imagine standing on the surface of a distant moon, under a dim orange sky. The light from the sun is faint here, filtered through thick layers of haze that cover the entire world. The air feels heavy, and the horizon stretches across a landscape that looks both familiar and alien. In the distance, dark liquid lakes shimmer faintly in the weak sunlight. Long rivers cut across frozen plains, slowly winding through valleys and basins. Clouds drift silently overhead, forming storms that will one day bring rain. But this is not rain made of water. On this world, rain falls as liquid methane. Above the horizon, a gigantic planet with glowing rings hangs in the sky, unmoving and majestic. This world is Titan, the largest moon of Saturn, and one of the most fascinating places scientists have ever discovered. For decades, Titan was hidden beneath a thick orange atmosphere, making it impossible to see its surface from Earth. Astronomers could only observe a mysterious orange sphere orbiting Saturn, with no idea what its landscape looked like beneath the clouds. But over time, new technology allowed scientists to slowly uncover Titan's secrets. And what they discovered changed the way we think about planetary environments, and even the possibility of life beyond Earth. Titan is an extraordinary world. It is the second largest moon in the solar system, even larger than the planet Mercury. Unlike most moons, Titan has a dense and complex atmosphere. In fact, Titan's atmosphere is thicker than Earth's. The surface pressure there is about 50% greater than the pressure at sea level on Earth. Most of Titan's atmosphere is made of nitrogen, the same gas that makes up most of Earth's air. But Titan also contains large amounts of methane and other hydrocarbon molecules. These chemicals play a role on Titan similar to the role that water plays on Earth. On our planet, water evaporates into the sky, forms clouds, and eventually falls as rain. On Titan, methane does the same thing. Methane evaporates from lakes and seas, rises into the atmosphere, condenses into clouds, and eventually falls back to the surface as rain. This process creates an entire methane cycle, very similar to Earth's water cycle. As a result, Titan has rivers, lakes, and even large seas across its surface. The largest of these seas is called Kraken Mare. Kraken Mare is enormous, stretching more than 1,000 kilometers across Titan's northern hemisphere. It contains vast amounts of liquid methane and ethane, forming dark reflective surfaces that resemble oceans when viewed from orbit. Radar images taken by spacecraft have revealed coastlines, islands, and complex channels where methane rivers flow into these seas. Some regions of Titan contain hundreds of lakes clustered together near the poles. In many ways, Titan looks like a colder and stranger version of Earth. But Titan's environment is far colder than anything we experience on our planet. The average surface temperature on Titan is around minus 179 degrees Celsius. At this temperature, water behaves like rock. The mountains and ground on Titan are believed to be made largely of solid water ice. Instead of stone mountains, Titan may have mountains made from frozen water that is harder than granite at those temperatures. Despite the extreme cold, Titan remains one of the most scientifically interesting places in the solar system. This is because Titan's atmosphere contains complex, organic chemistry. High above the surface, sunlight interacts with methane and nitrogen molecules. These reactions break apart simple molecules and allow them to recombine into more complex organic compounds. Over time, these compounds slowly drift downward through the atmosphere. Scientists sometimes describe this process as organic snow, tiny particles of complex carbon molecules falling gently onto the surface. These organic materials may accumulate over millions of years, forming thick layers across Titan's landscape. This chemistry is extremely interesting to scientists because organic molecules are essential building blocks for life. On early Earth, similar chemical reactions may have helped produce the molecules that eventually led to living organisms. In a sense, Titan may represent a kind of natural laboratory for studying the chemistry that occurs before life begins. But Titan also raises an even more intriguing possibility. Could life actually exist there today? At first glance, Titan seems far too cold for life as we know it. Life on Earth depends on liquid water, moderate temperatures, and complex biological chemistry. Titan does not appear to provide these conditions. However, scientists have begun to consider a more unusual possibility. Perhaps life on Titan could exist in a completely different way. Instead of water-based biology, organisms might use liquid methane as their solvent. Instead of oxygen-based metabolism, chemical reactions could involve hydrogen or other molecules present in Titan's atmosphere. These hypothetical organisms would be very different from life on Earth. They might move slowly, grow slowly, and survive in extreme cold. Their cell structures, if they exist, might be built from completely different chemical materials. Scientists refer to this idea as exotic life. It represents a form of biology based on chemistry very different from what we see on Earth. While there is currently no evidence that such life exists on Titan, the possibility remains scientifically interesting. The exploration of Titan took a major leap forward during the Cassini-Huygens mission. In 2005, the Huygens probe separated from the Cassini spacecraft and descended through Titan's atmosphere. For over 2 hours, the probe slowly parachuted through thick orange clouds, sending images and measurements back to Earth. As the haze cleared, the probe captured the first direct images of Titan's surface. Scientists saw branching river channels, rounded icy stones, and landscapes shaped by flowing liquids. When Huygens finally landed, it touched down on what appeared to be a dry riverbed. The ground looked similar to a river delta on Earth, suggesting that methane liquids had once flowed through the region. Since that historic landing, scientists have continued studying Titan using radar instruments and remote observations. They have mapped dune fields stretching hundreds of kilometers across the equator. They have observed seasonal weather patterns, including methane storms and rainfall events. Some models even suggest that Titan may have a subsurface ocean of liquid water buried beneath its icy crust. If such an ocean exists, it could provide another possible environment where life might develop. The exploration of Titan is far from over. NASA is currently preparing a new mission called Dragonfly. Dragonfly will be a robotic drone designed to fly through Titan's thick atmosphere. Titan's low gravity and dense air make flying surprisingly easy compared to Earth. The Dragonfly drone will move from location to location, exploring different regions of the moon. It will analyze the chemical composition of Titan's surface, study organic materials, and search for clues about prebiotic chemistry. The drone will explore dunes, impact craters, and possibly regions near ancient methane shorelines. Each flight could reveal new information about Titan's complex environment. Every measurement may help scientists better understand how organic molecules behave in extreme conditions. And perhaps, whether Titan could support some form of life, even if that life is very different from what we know. The discovery of life beyond Earth would be one of the most important scientific discoveries in human history. But if life does exist elsewhere, it may not resemble the life we see on our planet. It may live in oceans hidden beneath ice, It may survive in clouds high above alien worlds, or it might exist in environments once thought impossible, like the methane lakes of Titan, hidden beneath thick orange clouds, far from the warmth of the sun. Titan continues to guard its secrets. So the real question may not simply be whether life exists on Titan. The deeper mystery is this: if life can emerge in environments so different from Earth, how many other strange worlds across the universe might already be alive, waiting for us to discover them?